Second part of Chapter 3 is about the measures of variation. There are 4 measures of variation that we're going to look at. The range, which we already talked about, variance, standard deviation, and coefficient of variation. Alright, let's sort of review to start with. We want to find the mean, median, and mode for each stock. Mean, median, and mode, if you'll recall, are measures of center. We want to let the calculator do the work, so we're going to put stock A into L1, we're going to put stock B into L2. Now we want to find the mean, median, and mode for each stock. To find the mean, median, and mode for stock A, we just need to do stack, calculate, one variable statistics. We could just hit enter twice, because if our data is in L1, we don't need to tell the calculator anything. To find the mean, median, and mode for stock B, we need to do stack, calculate, one variable statistics, hit enter once, type in L2, then hit enter again to get the mean, median, and mode for stock B. When I do that, I get the exact same answers for the mean, the median, and mode. What that means, if I look at my two stocks, even though they don't look like they perform the same way, they are centered in the same place. So the difference between the two stocks is not going to be where their centers are, but in how much the data items vary. Our first measure of variation is the range. Now we already knew how to find the range. It's the maximum minus the minimum. So if I do that arithmetic for stock A, I get a range of 11. If I do that arithmetic for stock B, I get 57. Now that shows a significant difference. The problem is the range only takes into account the highest and the lowest values, not anything in between. So if you've got any outliers, remember outliers? The range is going to be overly inflated just because of one sort of misplaced data value. So it's hard to trust the range. The standard deviation, though, the standard deviation takes into account every single data item. There's a formula, a procedure that we do to find the standard deviation, and it's actually different if our data is a population versus the data being a sample. So when you do this, you'll get a different answer for a population than you do for a sample, which means your calculator will give you two different standard deviations. You have to be able to pick off the correct one. Both are not correct for your data set. Your data set is either a population or it's a sample, so you have to pick the appropriate standard deviation. Variance, if you've worked the standard deviation formula by hand, would be the next to the last step. Since we're not going to work it by hand, we're going to have to find it separately. So, again, calculator, if we do stack, calculate, one variable statistics, will tell us our standard deviations. Those numbers come up with the sample standard deviation symbol, and that tells us that not just are my highest and lowest numbers spread out, but in my stock B, all the numbers are much more spread out than they are in stock A. Look at the symbols. S is standard deviation. S squared is the symbol for variance. So if I know what the standard deviation is, how do I find the variance? I square the standard deviation. Now the symbols for the population standard deviation and the population variance, different base symbol, but the same principle. If this is the standard deviation for a population, you square that answer and that'll tell you the variance. Now if I want to find the coefficient of variation, what that means is I take the standard deviation and I'm going to turn it into a percentage of the mean. So the standard deviation divided by the mean. And this answer is supposed to be a percent. So I multiply it by 100 so that my decimal is in the correct place for this to be so many percent. I use coefficient of variation when I want to compare like apples and oranges, two things that aren't the same. The formula was standard deviation divided by mean. So if I start on the left, standard deviation is 3.02 and the mean was 68.43, or excuse me, I'm dyslexic, 34. So 3.02 divided by 68.34 times 100 means this answer in percent notation is not 4.42 but 4.42%. If you don't have the percent sign, it's wrong. To do the weights, 26.33 divided by 172.55 times 100 gives me 15.26%. When I compare these two, since I'm talking about heights being measured in inches and weights being measured in pounds, percents are comparable where inches and pounds aren't really. So to say this variation is 4.42% between the standard deviation and the mean, the heights are much closer together. They have less variation. The weights have more variation.